I'll still tell you a bit more about the amazing world of monorepos. Hopefully, I'll fill some gaps that you might have. Before we start, how many of you are using NX in their projects? Quite a bit. Cool. Hopefully, next time when I'm here on this stage or in this audience, it will be everyone holding hand. But before I start, I have a disclaimer. You see, in the following slides, there might be some examples of extremely bad design, some flickering colors, and some life-changing features that might blow your mind and change your perception of development forever. So in case you have a medical history with any of these symptoms, perhaps it's best if you step out and wait for another 30 minutes for the next talk. Otherwise, I just take the full responsibility. So whatever happens during this talk, it's on you, not me, sorry. And on that official note, just to briefly introduce myself, as Dariusz mentioned, my name is Miroslav Jonas. I'm based in Vienna. I work for Narval as a core member of NX, and I co-organize Vienna.js and Angular Vienna meetups. Now, before we dive into what monorepos are and how they work, in order to understand truly how we came to the point where monorepos are a necessity, let's take a trip back all the way to the past, to the very beginnings of the web, and let's retrace our steps. In the beginning, the web was static. It was merely a collection of HTML pages linked by hyperlinks. And the first web pages looked like this Yahoo page. There was a lot of text, some contrasty choice of colors, very small images, because if some of you remember, back then we had this like wooden boxes that we called modems that operated on dial-up and was super slow, so everything has to be very tiny in order to come in some reasonable time. But these pages were quite boring, and we needed some dynamicity. So folks decided that they will bring some animated images. Remember these? Or the dancing baby? Now, some websites weren't satisfied with just a couple of these. They decided, let's make entire website out of these animated images. It was cool, it was flashy, but it still wasn't dynamic. It lacked the controlled movement. So a company called Netscape, that was popular back then, gave a task to their employee, Brendan Ake, to create a new language that would finally bring dynamicity to the browser. And he did this in only 2 weeks. This language was called LiveScript, but it was soon renamed to JavaScript, much to the delight of generations and generations of headhunters and recruiters ever since. And we went into age of scripting, which was symbolized by fancy menu effects, and image galleries that were completely dynamic, and occasionally some buttons that would run away from your cursor as you move your mouse. But the pages were still ugly. That didn't help them, but then now they had controlled movement, right? So that was a big step up. And as the number of these scripts on pages grew, also common patterns emerged. This was also the time of the infamous war between Microsoft and Netscape, where each of them were pushing their own DOM agenda, and we as developers needed to solve that. So we needed some abstraction that would abstract those differences between two browsers into common functions. And this is how our first UI helpers were born, most notably jQuery. But abstracting away DOM manipulation wasn't enough. There was still a lot of boilerplate that we came to use. And this was the first time that we stopped calling our websites, and we started calling them web apps, because they suddenly had functionality that the apps that we were running on desktop had. So some of those boilerplates were routing, state management, event handling, different architectural problems. And all this led to the birth of single-page applications. First superstar frameworks were born. First of them, Angular, followed quickly by React and Vue. And all of these frameworks are still there today, and they completely changed our perception of front-end development. But badly for them, this was also the time when our mobile phones became smart. And suddenly, people were no longer surfing the internet on their desktop computers with stable connections, but rather they started surfing the internet on mobile phones, on trams, on park benches, or toilet seats. And in some of those locations, your connection was quite poor, and it was 3G at best. So we had these large websites. It was as if you were trying to squeeze a large elephant to a small straw. So we needed to address this. We needed something that was light and fast, in contrast to the big SP applications. Also, the web crawlers at that time didn't really like those single-page applications. All of this led to the age of JAMStack, which was introduced by meta frameworks like Next, Nuxt, Gatsby, or today, Remix, Astro, Quick, or this one over here. Anyone knows this logo? It's analog. It's built on top of Angular, and it's built by Brandon Roberts. Check it out. Amazing project. So this is finally something that's worth competing with all of these in the picture. Of course, we had Scully before this as well. That was a good direction, a good solution in this whole direction. But meta frameworks were speeding up the rendering of the applications, and our website were now super small, and they were super fast for users, but all of this came at the expense of developers. In order to have these sites super small, we had to bundle them and compile them during the development time. And also, this was the time when we pushed all of this heavy lifting to our CIs and CDs. So now, no longer you had only frustrated developers that were waiting for minutes and hours to have their builds compiled, but you also had now steep monthly price tags on your CIs. So it was time to address this developer experience, and this led to the age of monorepos. Now, to truly understand what monorepos bring to the table, let's see what typical application looks like today. Usually, there is some front-end application built with your chosen framework, for example, Angular. Then there's some backend. And the backend today is mostly not monolith. It's just some microservice architecture behind a common proxy. And on the other hand, you have some UI components library, whether custom or third-party built. And what happens often is that some colleague of yours in some backend team changes slightly one method in one service, and they simply forget to inform you, the maintainer of front-end solution. And suddenly your project is broken in production, everyone's pointing finger, and you're like, I don't know, I didn't touch that code, what happened? There are some clunky attempts where you can try to export the contracts from your APIs, pack them as TypeScript types, bring them to the front end, but this requires human intervention. And human factor, as we know, given enough time, will eventually fail. And even so, it still requires a lot of syncing because both backend and frontend have to be rolled out at the same time. And that might not be the only application. You might have other front-end application using the same backend and same UI component. Or you might have some utility library that's used just by some of them. And what happens now if you want to make change? What often happens is that some of those applications get left behind because they are stuck in some feature loop and they just can't afford to chase new versions. So they remained, for example, running backend on version 1. One of them runs on version 3, while the third one runs on some version 2 beta. And the same thing can happen with UI components as well. Now, you might think, that's fine because we have package.json, and it's fine if they have different versions. Doesn't matter. But what if these different versions also depend on different external dependencies? And now suddenly you want to introduce a feature that requires the latest TypeScript. But you can't because all of these applications depend on different versions of TypeScript. All of this leads to a frustration of developers. So how can we solve this? By collocating them in a same repository, we can make sure that they use the same set of dependencies and that they can see each other and talk to each other. By having them at the same place, for example, if we have some function in our admin portal, something like this super sophisticated, super secure admin function, we can say, hey, we have our homepage app, and they also need this secure function. How can we use it? Well, we can wrap it in an external library, and then have this library be shared between these two applications. And you can always extract common functionality, pack it in the library, and share it across different solutions. And it's a very fast and very easy process. You no longer have to go through all these ceremonies of publishing to NPM or your local repository or having symlinks between projects and then making sure that everything is fine. Because with publishing, if you publish a version, you use it in one application, maybe it works, you try in another, oh, it fails. Back to the drawing board. Again, fix it, try it out in demo, then again republish new version, and it's on and on and on. If you can just extract it to library, you can immediately see across all the application, is this okay or not, without the need of publishing. And most people think that monorepos are all about collocation, and it's just one big monolith that now suddenly has one modern fancy name. But it's not just collocation. Collocation is merely a precondition to everything else. It's the speed that's the main selling point of monorepos. So how do we achieve this speed? One of the things that was already mentioned today is the affected graph. When we know how the things are together, we can also see how they are connected. So based on the libraries and their imports in between them, we can see how this graph would look like. So for example, we can see that here we have 3 applications on top. 2 of them are front-end, 1 is back-end, and underneath we have this material blob, which are our UI components. And we can also try to isolate scopes. We can say that this is admin scope, that's store scope, API scope, and this on the bottom is our shared scope. And when we know how our scopes look like, we can decide how we can communicate between different scopes, what is allowed between different scopes. Also, when we know how things are connected, we can say, if this library over here is changed, let's say it's some data access types, we can say that based on this graph, the only 3 libraries that are directly affected are these 3, and sequentially also these 3 applications. So by knowing how they are connected, we can simplify this graph to just these 7 nodes. But let's say what we want to run is deployment. We know that this library is not deployable. It's just one small library. There's nothing to deploy there. And neither are these 3. But we know that our applications are deployable. So by knowing how things are connected and what we want to run, we can simplify the graph to just these 3 nodes. So by running affected plus deploy, we will reduce this graph to just 3 applications. And imagine your repository had hundreds or thousands of projects. How much would you save by that? But having things marked as deployable or ready for deployment doesn't necessarily mean that you have to deploy it. So it's not like someone is forcing you now, suddenly when it's affected, it has to be deployed. No, you can still decide admin is deployable on Tuesdays, API every 2nd week, store whenever it changes. It's up to you to decide when you want to do it. NX or monorepos just tells you that it's ready and that it should be deployed because there are some changes. When we know how things are connected, we can also get always up-to-date graph. So no longer you have to search through your network drives for some outdated legacy diagrams that were created by some architects that are so far away from the reality that they barely match the system at the moment. With monorepos, you get always up-to-date diagram. So you can see how all the nodes look like in a system. You can select one specific node and see the subgraph of connected nodes. Or you can select one small scope of the nodes, and then you can point to 2 nodes, select a starting point and ending point, and you can see what is the shortest path between these 2 nodes, or what are all the possible paths between these 2 nodes. Furthermore, you can see here that these nodes are connected, but how do we know how they are connected? How does this happen? If we click on these vertices, we can actually see what files are involved in these links. So we can see here that between devkit and NX, there's a connection, and all these files here are importing NX from the devkit. So you can always trace the steps how things are connected. And this is super helpful when you have, for example, a circular dependency and you need to figure out how this circular dependency is happening. When we know how things are connected and how things depend on each other, we can also talk about orchestration. So let's say we need to run task, build, and lint, and test, lint, and build. And let's say our test depends on some build artifacts. So naive way would be to just run them sequentially by making sure that test goes after build. A smarter way would be, of course, to run lint and build in parallel because we know they don't depend on each other, and run test later. Or even smarter would be to start running test as soon as the first artifacts from the build are done that are needed for the first tests. One of the first tools in monorepo world in JavaScript that we were using was Lerna. But at the same time, big corporations like Google and Facebook had their own solutions. Some time ago, they decided to open up and to release these solutions to the world. But there was a small catch. You see, sometimes you might need a PhD degree to be able to set it up properly. And even then, once you master how to set it up and to configure it, you might need a dedicated person working only on this segment. That was not feasible for most of the companies. Luckily, some other companies came along and provided their own solutions that gave the same set of possibilities, but in a more automated way, where you didn't have to configure every single thing, but most of the things were automated for you. Now, let's see what are those features that were missing for the original Learn and from the original version. One of the biggest selling point, as you heard, is caching. It's a premise that you should never run the same command twice. If you're running, for example, build on your machine, we always check, do we have already results for this task in our cache? If not, we'll store it in the local cache. So the next time we're trying to run the same command, we'll just simply get the replay back. And what we cache is we cache the artifacts. For example, for build, that would be our dist artifacts. But we also cache the full logs. And we mark this based on a file system, on the command that's being run, on your package manager, so all the parameters that could influence that command. So if you would change your package manager runner, or if you would change just a single parameter in a command, we would consider this as a missed cache, because we don't know how this might influence the results or not. Now let's say you have your local cache and it's all working fine, but then you have a colleague in Australia that's running the same thing, and of course they have their own local cache, but they won't be able to share your cache. And it's kind of a waste of time and energy, and it's just bad for the ecology to spend CPU multiple times for the same thing. Luckily, most of the solutions have their remote caching. So for example, for NX, we have NX Cloud, which is our remote caching solution, or distributed caching solution, where every time we run something, we know not only cache it locally, but we also cache it on the cloud. So the next time when our colleague in Australia is running it, they're going to check first, is it in my local cache? If yes, we take it from a local cache. If not, we will check the cloud. If it's there, we will grab it from a cloud. So they don't have to run it. And this is super helpful. For example, in the morning, you come to work, you fetch the latest master, and you simply run the build. In most cases, you will get the response immediately because it will be just taken back from the CI cache. Which brings me to the CI. So you not only save time on your machines, but you save a lot of time on CI. And saving time on CI means saving money for the company. Now, when we talk about these tasks running test and lint and build, it's not actually one blob that we're running. It's actually a set of small tasks that we need to run. Now, if we have just one agent on CI, normally we can run them sequentially. For example, select lint first, then build and test later. And we need to do this because some of the things in our test depends on build, and some build artifacts might depend on some other build artifacts, and so on. So our monorepo solutions give you this full chain of commands so we can trace back what things need to happen before I can do my task. But what if we have multiple agents? We can, of course, just split them into multiple agents and have one agent running lint, the other one build, and the third one test. But there's a lot of waste of time because the first two will be finished relatively quickly and there will be a huge idle time. Well, the third one is actually waiting until they get the first build artifact. So this is not optimal. What if we can just flip them around so that all of the agents start immediately and they try to finish at almost same time? But if you look at this, you might notice that in the first agent, there's lint, and then there's test. But where's build? We mentioned that all of the test tasks depend on the build. So if we look at this one, how does this one get the build artifact? Because we're running end-to-end tests, so we need build application to be able to serve it for end-to-end test. If you remember, we mentioned our caching. With caching, what happens is that we can build this artifact on some other agent. It will be cached on the cloud. And then once our end-to-end task requires it, it will be automatically given to it from the cache. So it doesn't have to run it on the same agent. And agents share their artifacts back to the main agent, which can then inform all the agents that are requiring certain artifacts that these artifacts are ready, that they can continue their work. And this also means that if we have more agents, if we have more money, we can make it even shorter. And ultimately, if you have endless amount of agents, this will last as long as the longest task lasts. But of course, it's not realistic that you have endless amount of agents, and it will be super expensive. Sometimes you can only afford 2, but it's also fine. We'll still manage to order those tasks so that it's optimal consumption of the lifetime of these agents. And eventually, if you look at the response, you would get something like this. So you can see that each of these agents spent working on different number of tasks. So one worked on 13, 14, 17, 12, 14. So each one of them worked on different amount of tasks because those tasks had different duration. But when you look at the consumption, they nearly finished at the same time. Of course, there are some slight variation, but it's not much of a difference. And if you want to set it up on a CI, this is all you need, for example, for GitHub. But I know what you're thinking. I'm not a DevOps developer. I don't want to do this. That's YAML. I don't want to set that stuff. Luckily, we have also command in NX, which will generate the workflow. You can just specify whether you want Azure or GitHub or Circle CI, and we will generate the basic solution for you, and then you can later modify it and improve it. But you would get standard setup with linting, testing, and building setup. As you can see here, we're running NX affected, meaning that we won't build everything. We just build the things that are affected. And we are also choosing here to run it across 3 different agents. So we specify our agent count would be 3, and we run it in parallel with number 3. The next thing that's cool about monorepos is that, as I mentioned, you can have these scopes, and you can define how you want to isolate scopes. Sometimes it happens that you are working on a feature, and it's a very experimental feature, and you don't really want anyone to mess up with that. But someone finds your commit and finds the feature, and they think, whoa, this is cool, I can use that in my project. And suddenly, you have someone depending on your code, although your code is still being heavily implemented. And now, every change you make during your experimentation might potentially break their project. Or if you decide that actually you don't even want this, it was just a bad experiment and you want to throw it away, you can't because someone depends on it. And now you have to maintain a feature that you yourself don't use. With code constraints, this is your only tool against unmanageable architectures. So if you look at this graph, for example, we can see how things are connected. And if we say that our store, which is written Remix and has one feature called Checkout, and our admin, which is in Angular and has 2 features, sales and coupons, we can assume that these, for example, the left side is written in React, the right side is in Angular. So we definitely don't want our sales that have some Angular code to try to read from a library that has some React code, because there might be some weird situations. Also, the vice versa works. Also, you don't want your shared libraries that are most likely just TypeScript libraries that don't have any framework-related stuff to suddenly import the full application and imagine breaking the routing completely. Not to mention that you would create a circular dependency in this case. So you want to prevent this. How do we prevent this? We prevent this using our linter, where we define our rules, what is possible and what is not possible. So here we can say that everything that's marked with type util can only depend on something else marked with type util. So you cannot import something that's marked as type application or type feature or type routing or whatever other types you have defined. Furthermore, we can say that our type util should be framework agnostic. So we want to ban all the imports that have words React or Angular in them. This would make sure that we don't have accidental imports of these libraries in there. So what are the things that we can define there? We can define, as I mentioned, that they only depend on libs with certain tags, or that they not depend on libs with certain tags. Imagine you have a bunch of different tags, and it would be painful to always specify all of them -1. So sometimes just using invert, we're saying everything else is fine apart from this tag. Or, as I mentioned, you can specify that you want to ban specific external imports or specific family of external imports. Additionally, you can say that you want to ban transitive dependencies, because this is not really good. Transitive dependencies are tricky because they are not in package.json, so today they might be there. Once you install the next version, they might disappear. Also, we can specify that when we are checking these external imports, with the previous command, we were checking just the first immediate child. But with nested external imports, we can go all the way through the dependency chain and see if any of the children of our dependent libraries are using the external import that we want to specifically ban. And finally, maybe you actually want to have circular dependency. Most of the bundlers would complain, but I don't know, maybe you want to live wild and have some crazy architecture, so you can always switch it on if it's fancy for you. We would suggest not to, but it's up to you. So what if you have one project? I mean, all of this looked like something that makes sense for enterprise with bunch of applications, bunch of projects. So what if you have just one project? Should you still be using monorepos? Well, the answer is simple. Yes, absolutely. Because we also provide powerful generators. So think about schematics. And now imagine if you would run schematics from this nice IDE that gives you all the possibilities where you can select special generator, and it will show you all the fields that you can provide and what is their meaning. But not only that, it also gives you possibility to create some custom generators where you can tailor the existing library generator. Imagine that normally when you create a generator, it generates like a blank library with one file in it. Now let's say if you're always doing the same thing, like plugging always the same set of state management libraries, or having some specific 3D maybe implementations in it. You don't want to always have this boilerplate of copy pasting, copy pasting, copy pasting. So you create a generator that is a wrapper around native generator from Angular, for example, or NX, and gives additional information. Here, for example, our generator is specific one for util libraries, and it doesn't do much. This one just prefixes our library with util dash, and it also makes sure that we have a proper type set for our module boundaries, and it also sets the scope. So it makes sure that you don't have libraries that don't have any text setup. But you can really go crazy with this. You can build a bunch of stuff. We, in NX, internally use this for all our plugins. So all the things that you can generate with NX, all of this is done with functions like this. And you can check our solution. There's a bunch of different examples what you can do with this. Also, generators are not the only thing. We have also our targets, which I mentioned, this build, lint, test. But these are not the only ones. So standard with framework, you get only these. But you can also create your own. Think about a situation where you have, for example, your website, and you have a bunch of images that you need to scale down for the web. You don't want to play around with Photoshop every time yourself. You can just have an executor that would run through all the images, scale them down, create them maybe variants for different resolutions, and prepare them for the compile time. And also, you don't want to do this over and over. You want to create an executor that is cacheable so that if images are not changed, you won't have to recreate them again. And it also brings consistent tooling. Now, most of us are using just ngserve. But sometimes, if you switch between different frameworks, you always have to remember, was it ngserve or npm serve or npm start or npm develop or something like this. And it's always different set of parameters as you switch between different commands. And it just forces you to remember these things. Of course, you can have this nice ID that will do this for you, and you don't have to remember. But monorepos also provide a consistent tooling. So you always start your application with serve, you build them with build, you test them with test, you lint them with lint, you run end-to-end tests with end-to-end, and always the parameters are same. If you specify parameter, it's the same. Parameter, for example, parallel, it's the same for everyone. If you specify the name, it's same for everyone. And how do you start? You can just go ahead and create new workspace, or you can migrate existing monorepo if you have one. Or you can just convert the existing Angular application by using this command. So you can quickly dive into it. So let's recap. Monorepos bring us clarity by giving us workspace analysis and graph visualization. They also bring us speed by leveraging local and remote caching, by giving us task orchestration, by giving us a mechanism to detect affected graphs and distributed task execution on the cloud. And finally, they make it easy for us developers because they give us code sharing abilities, code collocation, powerful generators that can be tailored up to your needs, consistent tooling, and code constraints. And finally, it's not just a fancy tool that you use for developers. It also changes the way your organization works. It gives you greater developer mobility because when you're working together on the same solution, you can easily switch developers between different teams. You also get collaboration by default because now people are forced to work together. They are no longer teams that are competing each other, but they are working together towards the same goal. And this changes the organization completely. And all this brings greater confidence in the code, and it creates bigger velocity. If you want to hear more about different monorepo solutions, you can head over to monorepo.tools, where there's a nice comparison between different solutions. Or you can just take my word and use NX. It will give you all the tools you need, all the implementation you need, and it will solve even the problems you didn't know you had. So stop wasting time waiting for those builds, and stop wasting money on those CI pipelines and spend it on something better like these conferences. So why be 10x developer when you can be an X developer? Thank you.